Hi everyone, welcome to AS Engineering Academy, AS Preparation League Season 2. This is Ramesh, faculty at AS Engineering Academy. Now I am going to take the discussion related to important concept from electrical and electronic measurements. In this entire thing, especially I am focusing only on electrical measurements now. Right? From that, I am taking one special topic, very important topic, which comes under electrical measurement category. That topic is measurement of power. Measurement of power. That measurement of power topic is common for both the branches, electrical as well as instrumentation people in the gate point of view. And it is not there ECE. ECE people in the ESC, the topic is there. So that's why the topic is common for three branches, we can say. Gate, electrical instrumentation. ESC if you are taking, that is for electronics people. The topic name is measurement of power. This is one of the most important topics in the electrical measurement category. As I discussed in the earlier session, that is preparation strategy, so many chapters we have taken, right? One of the important topics is measurement of power. Of course, other topics also equally important, but this is playing the major role in terms of conceptual approach, in terms of scoring wise. So this topic is very important. That's why I'm taking measurement of power. That too, this is the topic common for all the branches like electrical, instrumentation for gate and ESC also, and electronics people ESC. That's why I have chosen this topic. Now in this session of 1 hour of time, I cannot cover entire measurement of power chapter. That's why first starting time I will be taking what is the basic idea about power, right? What are the measurement methods of power? After giving that introduction, I am going to take in that measurement of power methods, one important topic is there. Very popular method. In any mission, in any practical structure, measurement of power is done by that method. So I am going to choose that method. I will explain the concept of that method. After that, on that corresponding method, we are going to take some questions. Right? Once we are solving the questions, you can get the idea, okay, this is the way of solving the questions when wattmeters are connected. Either 2 wattmeters may be there, or 3 wattmeters may be there, or 1 wattmeter may be there. So that's why you need to focus Right. In this, I am going to take the measurement of power. Few questions only I will be taking. Then you can understand, okay, 1 watt meter, 2 watt meter, or 3 watt meter method, how the question should be solved. Right. Now, let us start the topic, measurement of power. In order to measure the power, there are different classifications available. The power measurement is classified into two types. First, DC power measurement, and other one is AC power measurement. As we are having the two supplies, right, we need to talk about DC power measurement as well as AC based on the supply. And in the DC power measurement, what is a DC power? First of all, P average is equal to V into I. Sir, in order to measure the DC power, what is the procedure? You know, in order to get P average, what we require? V average into I average. So therefore, we can use PMMC instrument. So PMMC instrument not as a wattmeter, PMMC voltmeter as well as PMMC ammeter we can use. Sir, how? Means PMMC voltmeter gives V average. Yes, V average we require. PMMC ammeter gives I average. If you are multiplying these two readings, automatically P average will be available. This is the simple introduction regarding DC power measurement. Coming to AC power. Sir, in the AC supply again, two parts are there. One is single phase, another one is three phase. Sir, in the single phase, what is the formula? P single phase is equal to V phase, I phase into cos phi. V phase, I phase into cos phi. Sir, in order to measure this single phase power, there are, what is it? Wattmeter approach methods are there. One is MC short and then LC short methods are there. Right? This is EMMC instrument. EMMC instrument, in that MC short connection is possible, LC short connection is also possible. In these two methods, we can get the corresponding single phase power measurement. And coming to three phase power, what is the three phase power formula? Power three phase is equal to root 3 VL IL into cos phi. Generally known formula, root 3 VL IL cos phi. But sir, in order to measure the three phase power, there are three types of methods. One is 1 watt meter method, 3 watt meter method, and 2 watt meter method. Sir, 2 watt meter method is popular among all those three. That's why in this session, in this 1 hour of session, I am going to take 2 watt meter method concept. What is the procedure? Then I am going to take few questions, numerical questions, how to solve the corresponding questions. So before going to that, let me write the data here. First method is 1 watt meter method. 1 watt meter method, right? And 3 watt meter method and 2 watt meter method. So these are the total methods available. This is a simple introduction regarding measurement of power. But as I already told you, this entire measurement of power chapter is biggest one. In this 1 hour of session, I would like to cover only one part, that is 2 watt meter method I am taking. Why means, among all this, of course, each and everything is important, but among all this, very, very popular method is 2 watt meter method. That's why I am going to take the basic idea regarding 2 watt meter method concept, and then we are going to solve the numerical questions. Let us start the 2 watt meter method. Now, in this 2 watt meter method, what is the basic concept? Then we'll be taking the circuit, phasor diagram and approach completely. Let us take. So what is the meaning of 2 watt meter? You know, sir, power 3 phase, whatever the power we want to take, power 3 phase is equal to 2 watt meter readings are there. Therefore, W1 plus W2 both must be added. Right? W1 reading, W2 reading, both must be added and equated to which value? The total value. Means these two values are added, then it should be equal to 3 phase power. Means we need to get definitely this combination is root 3 VL IL cos phi. If you are getting that value, yes, we can say yes, 2 watt meter method is completed, etc. In that way, we need to conclude this method. So therefore, what is the wattmeter reading is important. What is the second wattmeter reading is important. And after adding, how we are getting entire approach is very, very important. So therefore, I am going to take wattmeter 1 connection, wattmeter 2 connection, wattmeter reading, wattmeter other reading, etc. Both must be added to get the corresponding 3-phase power. This is a simple history related to the corresponding 2 wattmeter method. Now, sir, 3-phase systems are generally, this is 3-phase power notation. 3-phase connections are generally two. One is star connection, another one is delta connection. Explanation point of view, I am taking star connection. Explanation point of view, I am taking one star connection here. This is the star connected circuit. This is the star connected circuit. No, sir, 3 loads are there. 3 loads are there connected in star. This is the neutral point, right? Now, explanation point of view, I am taking the load as the balanced load. Suppose in the numerical point of view, sir, if the load is unbalanced, no need to worry. Yes, procedure is similar based on the corresponding key point I am going to give you. Follow that, you can solve any question. That is, here I am taking Z, Z and Z. Means I am taking balanced load as the example. If you understand everything related to balanced one, automatically corresponding procedures will be very simple. Okay, what is that? Be clear. I am taking this terminal as R, this terminal as Y, for example, this terminal as B. For example, I am taking R, Y, B, 3 terminals I am taking. Sir, in this, I have connected 2 wattmeters such that wattmeter is connected in R phase and return path will be given here. Means for this wattmeter 1, which is acting as return path, B line is acting as return path. Same way, wattmeter 2 is connected, the return path will be acting as, B is acting as return path. So therefore, the 2 wattmeters should be connected such that one line must be acting as a return path. That is what the first point, right? You can connect R to B, Y to B. I have taken like this, but you can take B to Y, R to Y, otherwise B to R, Y to R, anything you can take it, no problem. One of the connections I'm showing. Be clear, it doesn't mean that it should be always like this only. No, you can take R to B, Y to B, no problem at all. Clear? Okay. In order to proceed further, we need to understand one point here. Sir, whatever the current flowing here, this is called as I line current. I line we can say, I line. The terminals based parameters are line. So this current I am taking as IR. So same current is flowing over here, that is IR. Same current is flowing, that is IR. Sir, why? Means the potential coil carries very small current. Practically we can neglect it. That is a concept. Okay, right. After that, here this is IB. This is IB. Just terminology I am giving, IB. And this is IY. This is IY. So therefore, this IY is going through this. This is IY and this is IB. Only terminology direction I am giving. After that, based on the corresponding connection, we will take the power flow. Simply IR to the neutral point, IB to the neutral point, IY to the neutral point. So this is a general connection. But sir, this is the return path, current should come out. We will be taking that later. Normally, what is that? Magnitude notation I am taking. Okay, after that. Sir, what is the wattmeter reading? In order to get the wattmeter reading, we need to talk about potential coil connection as well as current coil connection. If you are holding these 2 points, thing will be done. What is it? Let us see. In this IR, this is a line current, this is a phase current. That's why in the star connection, line current equal to phase current. Right? Everyone knows this basic point. Line current is equal to phase current. In which connection? Star connection. Okay, after that. Sir, if I write the voltage terminology like this, for example, what is this? This is the voltage from R to N. This is VRN. This is VRN. This is equal to V phase we can say. VRN, V phase. Okay, after that. Sir, if I take this as VBN, VB to N terminal. This is VBN. Okay, after that I am writing here VYN. VYN. Now, the point here is all these three voltages are line voltages or phase voltages. All these three voltages are line or phase, means kindly focus. Sir, R to N means only one phase, therefore it is a phase voltage. Here also, B to N only one phase, it is also phase voltage, right? And Y to N, it is also phase voltage only. This is the terminology. V, RN, VYN and VBN phase voltages. Okay. Sir, what will be the line voltage then? Check it here. Sir, from here to here, if I am taking here to here, what is this value? This value is, sir, R to Y terminal. So I am taking this as VRY. I am taking this as VRY. Okay. Sir, why? R to Y I am taking, therefore RY. And here I am taking here to here VYB. VYB. So Y to B. And here to here, this will be taken as VBR. VBR. This is what the terminology. Now tell me, sir, R to Y, V to Y to B and B to R. So which sequence we have followed? RYB sequence. Therefore, assumption is RYB sequence I am following. If sequence is not mentioned in the question, generally RYB sequence is the general sequence to be followed. Okay, right. So this is the complete terminology regarding the star connection circuit. But our topic is what? Power measurement. So wattmeter readings we have to write. So kindly focus here. Sir, in order to get the wattmeter readings, you need to understand where the wattmeter is connected. That's why the simple point I'm giving, guys, this is the key point to solve any question related to wattmeter reading. Whatever may be the complicated diagram is given, don't get afraid of. Don't be afraid of that entire diagram. Don't get disappointed. Don't get deviated. What is that? Simply take the wattmeter 1. Take the wattmeter 1 reading. How means? So wattmeter means what? Power. So power means voltage, current into cos of something. Angle between those. Therefore, voltage, current and cos of angle between those two. First key point is this. Start like this. Then any complicated circuit is given, the thing will be very, very simple. Okay. After that, sir, W2 also. Wattmeter means voltage, current and cos of angle between those two. Okay, now be clear. If you are able to write these two equations perfectly, yes, solution is done. Simple mathematical graphical, that is phasor diagram based only. That's why these two equations obtaining is very, very important in this measurement of power. So kindly focus. Sir, wattmeter 1, check it here. This is the coil called as potential coil. That is the reason why it is connected in across or connected in parallel in the supply. So therefore this is PC, this is called as CC. Here also this is PC potential coil, this is current coil CC. Now tell me, sir, potential coil is connected across which terminal and which terminal? Potential coil is across R and B. So we need to write RB. Sir, why RB? Wattmeter is in the R phase. Written path is B means the current will be flowing through this path only. So therefore R to B. Of course, the current is very small, negligible, but path I am showing VRB. So therefore the voltage across the potential coil is VRB. First point. Okay. Sir, current coil, current through the current coil is IR only. Current to the current coil is IR. So therefore simply IR. After that, cosine of the angle between VRB and IR. VRB and IR. If you are able to write this, thing is done. Openly speaking, thing is done. I am coming again with the second wattmeter reading. Everyone. Sir, potential coil is connected between Y and B. So therefore, in the Y terminal, wattmeter is there. Start with the terminal. What is that? V, Y to B terminal. So VYB. Voltage across this is VYB. After that, sir, current through the current coil is IY. Check it, IY. So therefore, yes, current through the current coil is IY. Very simple. After that, anyway, angle between these two, VYB and IY. VYB and IY. Very, very simple. Clear? So this is the complete important point in the entire, what is the measurement of power? Potential coil voltage, current coil current, cos of angle between those two. Potential coil voltage, current coil current, cos of angle between those two. If you are able to write this, thing is done. Simple electrical phenomenon, that is simply phasor diagram approach. Let us proceed with that. Let us proceed. Sir, in order to get the angle, definitely we should draw the phasor diagram. And that too, which sequence I followed? RYB sequence I followed. Sir, in this, load is, what is that? Balanced load. But lagging or leading, we don't know. Assumption is lagging. So therefore, I am assuming like lagging load. In the question, lagging may be there, leading may be there, resistive also may be there. That depends on the data. But as it is a concept, I am taking one of the loads, that is lagging load. Okay, right. Sir, this is VRB. Sir, what is VRB? VRB is the line voltage. Check it. Sir, VRB or VBR, magnitude is same but direction is reversed. But what is this? This is the line voltage. This is also line voltage. This is also line voltage. Why? Line to line, line to line. Here also line to line. Therefore, line voltage. Okay. Now, sir, VRB, it is a line voltage. Okay. But how do you get VRB with respect to phase values? Means simple. Simple note I am giving. Simply split into two parts. That is VRN minus VBN. VRN minus VBN. Simply split into two parts. VRN minus VBN. In the same way, try to answer. What is this? This is VYB. That is what? VYN minus VBN. VYN minus VBN. Of course, it is the phasor combination, vector combination we can say. Okay. But people doubt is, sir, how this is coming into picture? Very simple. Check it here. Sir, RB we require. What you require? RB you require. R is the starting letter, starting point. B is the second letter, that is ending point. So therefore, VRB means R to B notation we need to take. So therefore, VRB means we need to start at R, end at B, path is to be closed. Check it. What is that? R to N, N to B. What is it? R to N and N to B. So therefore, VRN plus VNB. Sir, plus VNB is there. Simply, I am reversing that minus VBN. Very, very simple. Same logic. YB. What is YB? We need to start at Y. We need to reach the B point. Check it. VYN and VNB. So therefore, minus VBN. Very, very simple. Okay. After getting these two, I can say half of the procedure is done. Main problem is done. Only simple phasor diagram approach. Okay. Now, sir, I am taking phasor diagram approach now. Sir, this is VRN. Right? I told you already, RYB is a sequence. So therefore, what is that? If this is VRN, this will be VYN. This will be VYN. And then this will be VBN. Check it here. 120, 120, 120. Why? I have taken Z, Z, Z. Simply balanced load I have taken. For example. So therefore, this is what the value. Okay. Sir, what is the type of load? Lagging load. How much lagging? 0.8 lagging, 0.7 lagging. We don't know. So therefore, simply lagging, you know. So therefore, as this is lagging, IR lags the VRN. But IR lags its own phase. So therefore, somewhere else I am drawing here. This is IR. Lags by how much value? We don't know. That is simply phi. Some phi. In the same way, what you require? IR is there. IY you require. So therefore, you need to draw IY here. This is IY. It is also lagging by 5 degrees. Lagging by 5 degrees. Clear? Okay. After that. Sir, you require VRN. Sir, it is there. Happy? And you require VYN. It is also there, happy. But what you require? That is minus VBN. Here also minus VBN is required. What you have to do? VBN is there. Simply reverse it. So therefore, yes, if you reverse this, it will become minus VBN. Minus VBN. After that, we need to start the corresponding process. What is that? Be clear. Sir, VRN vector minus VBN vector must be added. So therefore, VRN, I am drawing here, VRN and minus VBN. So combination of these two, that is equal to VRB. So therefore, straight away I am drawing the vector. Yes, this vector is VRB vector. VRB. Clear? Okay. After that, sir, VYN vector minus VBN vector is to be added. So therefore, sir, this is VYN, this is minus VBN. So therefore, again, what is that? VYN and minus VBN must be, what is that? Parallelogram addition. What is that? Combination here is, this is VYB. This is VYB. Sir, what we require? VRB, VYB. Got it? VRB, VYB. So 70 to 80% of concept is done. What is it? Writing the equations first roll, then phasor diagram and obtain the required parameters. Okay? After this, final step from this phasor diagram. Sir, what you require? VRB and IR you require. Angle between those two. Check it. VRB and IR. VRB and IR. This angle is required. Just I am writing. This is which wattmeter? W1 wattmeter. Check it. VRB and IR. W1 reading. Next. Sir, VYB and IY angle. Angle between VYB and IY. Sir, VYB is this. IY is this. So therefore, this angle we require. If you are able to get this, yes, almost 80 to 90% will be done. Only simple mathematics. Okay, this is W2. Now tell me, what is the angle? What is this angle? What is the angle between VYB and IR? VRB and IR, VYB and IY. So simply VRB and IR, VYB and IY angle is required. Okay, now, sir, what is this angle? Kindly follow along with me, right? Follow my hand movement. Sir, what is this angle? Everyone, kindly focus more. This is the key point. This is 120 degrees and sir, as it is reversed, up to this it will be 180 degrees. Kindly focus. This is 120. This will be 180. So therefore, this will be 60. This will be 60. Sir, if this is 60, half will be which value? 30 and other half will be 30. So therefore, what we can write now? Simply this angle is 30 that I am indicating. This is 30 and this is also 30. Kindly check it. 30 plus 30, 60 plus 120. Yes, 180 straight line. Satisfied? Okay. So therefore, if this is 30, this is 5. So what will be this angle? 30 minus 5. So therefore, the angle here is 30 minus 5. Clear? Same way. Come this side. Sir, here, this angle VBN to VYN 120. Here to here 180. So obviously, what we can write now? Sir, this angle is 30. This angle is one more 30. Check it here. Sir, 30 plus 30, 60 plus 120, 180 straight line, over. Now check it. Sir, this angle is 30, but we recur up to this. So angle will be 30 plus 5. If you are observing this, thing is done, 30 plus 5. One is 30 minus 5, one is 30 plus 5. In my example, lagging load I have taken now, W1 30 minus 5, W2 30 plus 5. Okay, right, just go back. So what is VRB? VRB is the line voltage. IR is, all I told you, IR, it may be line current or phase current, both are same. But here VRB or VBR, it is a line voltage. So therefore, in the place of this VL, IL we can write. So therefore, I am writing the result now. Therefore, W1 is equal to VRB. I'm writing here just L, VL. IR you can write it as line current or phase current based on your requirement. And into cos of what is this angle? 30 minus 5. So therefore cos 30 minus 5. Okay, right. After that, W2. What is W2? W2 is which one? VYB. It is also line voltage. Y2B line voltage. IY line or phase current as you wish because star connection. So therefore it is also VL IL cos 30 plus 5 over. If you are writing this, everything is done. Okay, but what is the first step I told you? In this 2 wattmeter method, W1 reading we obtained VL IL cos 30 minus 5. W2 reading VL IL cos 30 plus 5. So therefore, simply add these two. If you are adding those two, we need to get this value. That is what? 3 phase. So therefore, simply, yes, I am adding the corresponding parameters now. Therefore, W total is equal to W1 plus W2. What is W1? VLIL. Here also VLIL. I am taking common. VLIL common. Cos 30 minus 5. Cos 30 minus 5 plus cos 30 plus 5. Simply add these two. Over. Now, sir, cos C plus cos D. Cos C plus cos D. What you get? 2 cos and cos. So therefore, you are getting 2 cos 30 and cos 5. You will be getting 2 cos 30 and cos 5. Okay, so 2 cos 30 cos 5 is there. What is cos 30? Root 3 by 2. So therefore, I am writing the continuation part. W total is equal to VL IL 2 into root 3 by 2 into cos 5. Cos 5. So 2 anyway cancel. So therefore, what is it? W total is equal to W1 plus W2 equal to 2 cancelled. Root 3 VL IL into cos 5. This is what the corresponding formula. Got it? Yes, power 3 phase, root 3 VLIL cos 5. W1 plus W2 also root 3 VLIL cos 5. Yes, this is happily now we can say, sir, this is 3 phase active power. This is 3 phase active power. So that's why if you are having the 2 wattmeter readings with us, automatically we can get the corresponding, what is it? 3 phase power. So this is the complete concept of 2 wattmeter method to get the active power. But after this, so many topics are there. Sir, 2 wattmeter readings are there. We have added. We are getting the 3 phase active power. Okay, we got it. Active power. Suppose if we subtract the readings from one to other, we are going to get reactive power. And if you are combining active power and reactive power, that will give apparent power. Like that, all types of parameters can be determined. But I told you, in this session, 2 wattmeter method concept and how to get the power concept, how to get the power measurement, that concept will be taken. I told. Yes, this is the complete discussion regarding 3 phase power measurement by 2 wattmeter method. That's why the popular method among 1 wattmeter, 3 wattmeter, 2 wattmeter, the popular method is 2 wattmeter method. It is suitable for balanced or unbalanced. Right? What is it? Balanced or unbalanced, and star or delta, you can use it properly. No problem. 3 phase, 3 wire, balanced or unbalanced, you can use it blindly. I repeat, 3 phase, 3 wire, balanced load or unbalanced load, 2 wattmeter method, you can use it directly. That's why with this 2 wattmeter method, not only active power, reactive power we can get by subtracting these two. And by combination of active power and reactive power, apparent power we can get. And if you are proceeding further, power factor of the load also can be determined. Those many advantages are there. But as of now, only active power notation I have given. This is the total discussion regarding active power measurement. Okay. Now, based on this entire concept, let us proceed for different numerical questions, so that how the question will be given with 2 watt meters or with 3 watt meters, etc. How to get the corresponding value? Let us take that. Let us see the first question here. Right, in this here, the line to line input voltage to the 3-phase 50 Hz AC circuit shown in figure is 100 volt RMS. Be clear, he mentioned very clearly, very much clearly it is mentioned, line to line voltage, nothing but V line is 100 volt. V line is 100 volt. Assuming that the phase sequence is RYB, okay, phase sequence always RYB. The wattmeter would read dash. The wattmeter would read dash. Correspondingly, what is the corresponding reading of the wattmeter? Now, what is that? This is the circuit they have given. Okay, in this entire thing, wattmeter 1, wattmeter 2. Yes, wattmeters will read dash value. This is what he is asking. Wattmeters read dash. Okay, what is that? Sir, in this circuit, they have given, right? They have given from R to Y, B to Y they have given. So if the question is given, all I told you, we need to follow that connection only. And sir, phi at an angle 60, phi at an angle 60, again phi at an angle 60. So what is that? Balanced load is given. And with the given data, we need to understand that, sir, phi value, load power factor value, automatically what is that? 60 degrees is given. What is the power factor value? Cos 60 is 0.5. That's what the point. Okay. Sir, in order to get W1 and W2 reading, same procedure. What I told you, W1 reading. What is that? Potential coil excitation, current coil excitation, or potential coil voltage, current coil current. What is it, etc. Same procedure. Okay. Let us follow. This is the corresponding option they have given. We'll see that later. Sir, in this first point, undoubtedly first point should be the wattmeter reading step. Yes, so wattmeter reading 1. So what is the wattmeter reading 1 here? Sir, wattmeter reading 1, potential coil is connected between R and Y, so that VRY. So therefore here, what is it? V, right? W1 is equal to, what is that? VRY. Okay, now, so what is the current? Current through this entire thing. So one phase to neutral point. So IR phase is there, no? Simply IR. So therefore, what is the current? IR. So if you are observing these two, thing is done. Cos of angle between those two. Therefore, cos of angle between VRY and IR. VRY and IR. Very simple. So our duty is to get the angle between these two. Once you are getting that angle, thing is done. Okay, right. Second one. What is W2? What is W2? See that W2 is potential coil is now from B to Y. Potential coil is now from B to Y. So VBY we have to write. So therefore, what is that? VBY. After that, what is the current coil? Current through the B line. So therefore we can say IB. Okay. Current value is IB. Current value is IB. After that, cos of, what is that? VBY and IB. VBY and IB. This is what the actual point. Okay. Once we are having this, simply proceed with the phasor diagram. How? Before proceeding with the phasor diagram, I told you, no, VRY means, what is it? VRN minus VYN. VRN minus VYN. Because RY split into two parts, RN minus YN. Here also, VBY. So therefore, this will be VBN minus VYN. VBN minus VYN. Clear? Now, sir, Bn minus Yn, Rn minus Yn, anyway we need to go for phasor diagram. We need to get minus Yn from the phasor diagram. But in the question, they have mentioned RYB is a sequence that we need to follow. So therefore, in this I am following the RYB sequence. Sir, this is VRN. This is VRN. Okay, after that, this is VYN, VYN, and after that, this will be VBN, VBN. Okay, right, sir. R, Y, and B. Phase sequence we have followed is RYB. Check it here. R, then Y, then B. RYB phase sequence. Okay, right. Sir, which we require? RN we require. BN we require. It is there. But minus YN is required. YN is there. You need to reverse it. But before reversing that, let us indicate the current vectors what we require. IR and IB. Sir, what is the diagram? Just let us see here. What is the angle? Phi is 60. Therefore, IR, this is IR. IR lags the VRN by 60. Simply by own phase 60 degrees. Therefore, what we can draw now? Here, this will be the angle that is IR. This angle is 60. Why? Lagging load they have mentioned. Phi at an angle 60 means, yes, IR lags the VRN by 60 degrees. Okay, sir, IR is over. IB, where should be IB? IB will be lagging with the BN. So BN is there. So therefore, right, this will be, which one? IB. IB. What is this angle? 60 degrees. Okay, according to the given data we have written. After that, let us focus. Sir, minus VYN. Here many people are getting stuck up. Many people are getting doubt like, I have done the mistake, what should be the procedure, etc. They are unnecessarily wasting the time. Kindly focus. Sir, if minus VYN means VYN should be reversed. So if the VYN is reversed, so definitely it is along with the IB only. The moment along with the IB is there, people are thinking that, okay, some mistake is there. No mistake. This is correct only. Whatever you do, that is correct only related to this. Why means, as the angle is given 60, these two are matching with each other in phase. That's why that depends on the load also. So no need to worry. Okay, 60 degrees lagging is there. It is reverse. Check it. This is 120. It should be 60, 180. So definitely these two will be on the same phase. No need to worry. Okay. So therefore, this value is, what is that? Minus VYN. Okay. What we require? Minus VYN. We got it. RN, BN already there. Now, sir, VRN minus VYN. VRN minus VYN. VRN minus VYN means VRN and minus VYN we have drawn. Therefore, the final value is this one. This is VRY we can write. This is VRY. Okay, right. After that, what we require? VBN minus VYN. Check it here. Sir, VBN minus VYN is this. Simply add the vectors. Right? If you are adding the vectors, you are going to get the final value. That is this one. What is this? VBN YN means VBY. So therefore, this will be VBY. Okay. Finally, we have got VRY and VBY. Happy, no problem. But what we require finally? Angle between VRY and IR. Check it. Sir, VRY, IR. So therefore, this angle is required. This angle is required. What is this angle? This angle is W1 related angle. W1 related angle. Okay. What is this angle? If you see the diagram properly, you can understand that is 90. How? Sir, already 60 is there. What is this angle? This will be 30. So therefore, 90 degrees. So this will be 90 degrees. I'm coming again. If you observe this properly, sir, this angle is 30. This angle is 30. Okay, if this is 30, already 60 is there, automatically we can say that here to here 90 is there. So 90 degrees. Okay, leave it. Now second angle, what is that? Wattmeter to VBY and IB. Sir, VBY and IB, this angle is required. this angle is required. Sir, this is 60, half will be 30 automatically. Therefore, this is the W2 related angle, that is 30 degrees. So W1 related angle is 90, W2 related angle is 30. Okay, now let us proceed. Here in this, VRY, VL, IRY, IL or I phase, you can add both, no problem. So therefore, finally, W1 equal to VRY and IR, VRY and IR, cos of angle between these two is straight away, what is it? VRY, what is it? VRY and IR, angle is straight away 90. So therefore, without any second thought, we can write 90. Cos 90 is 0. So no headache at all. Simply 0 watts. Sir, wattmeter one reading is 0. In order to save the time, check the options. If you check the option, sir, W1 some value, W1 some value, W1, yes. So simply this is equal to W1 0, W1 0. This is nothing but W1 not and here, W1 is 0. So therefore, answer will be yes. So straight away, here W1 is this one. So option C. But sir, W2 is 1000 watt. How? Let us take that also. Sir, W2 is, kindly focus. VBY means V line. Okay, V line. And IB you can write as line or phase. So therefore, I am writing IL. Cos of, what is this angle? This angle is 30 degrees W2 angle. So therefore, cos 30. Okay, but small key point again. Sir, VL is 100. 100 is given in the question. Sir, what is IL? Generally, people are writing like, everyone, kindly focus. IL is equal to VL by Z. Never. Don't write like that. What is the basic point? First you need to write I phase is equal to V phase by Z. This is the actual terminology. Sir, why? I phase, V phase. Anyway, Z will be per phase only. Phase and phase. Everything will be phase only. Therefore, this is the valid formula. Okay. And in the star connection, V phase is equal to VL by root 3 by Z. And in the star connection, I phase is equal to IL. So therefore, in the star connection, I phase equal to IL, you can write. In the star connection, V phase equal to VL by root 3. That's why in the place of IL, you should write VL by root 3 by Z. What is VL? 100. So therefore, I am writing here 100 by root 3 by, what is Z? Phi at an angle 60. So magnitude phi and cos of 30. So automatically, if you simplify this, you are going to get the value of 1000 watt. You are going to get the value of 1000 watts. This is what the answer. So W1 is 0, W2 is 1000. Choose the option yes, that is given as 1000 only. In this way, you need to calculate the corresponding parameter to get the total power value. W1, W2, if he is asking that what is the total power, W1 plus W2 also you can do it. So this is a total example, clear-cut example of 2 wattmeter method. Clear? Right. To have more clarity, let us take one more question. This is little bit lengthy question, not complicated but lengthy question. Kindly focus. The question itself is very lengthy. Okay, kindly focus. The load shown in the figure is supplied by 400 volt line to line. Yes, okay. What is that given? 400 volt line to line is given. Okay, line voltage is 400. Okay. Phase sequence, of course, RYB given or not given. Generally, RYB is to be taken. If something else is given, follow that. Otherwise, RYB. The load is balanced. Very important. Load is balanced. And inductive means lagging load. And drawing 364 volt ampere. How much? 3464 volt ampere means this is the apparent power. Because volt ampere means apparent power. What is given? S is given. Okay. When the switch S is in position N, If you see the diagram, you can understand. What is that? This is the figure. 400 volt supply, this is the load, this is the figure they have given. Sir, this is a switch. When the switch is at n position, right? What is that? The given data is value. What is that? Let us see. When the switch is at n position, the 3 wattmeters W1, W2 and W3 read 577.35. When the switch is kept at n position, each and every wattmeter is reading 577.35 each. So each wattmeter is equal means what is the total power into 3 or 577.35 plus 577.35 plus one more 577.35. You will get the total power consumed by the load. What he is asking actually, after this, if the switch is moved to position Y, the readings of the wattmeters in watts will be. So that is what the actual point. Means switch N they have given, switch Y, what is the corresponding wattmeter reading? That is what we need to calculate. Okay. Now let us proceed with the corresponding thing. This is the figure. Okay. Sir, when the switch is at N, try to understand the concept. When the switch is at N, you need to understand the wattmeter connection. What is that? Here, W1, voltage I am taking. VR to N. VR to N means VRN, one phase. Anyway, IR, VRN one phase, IR phase. So therefore, wattmeter reads phase power, single phase power. Check it. V, Y to N. Again Y to N because switch is at N position starting. So Y, kindly follow my hand movement. V, Y to N. V, Y, N. It is also phase voltage. And then V, B to N. V, B, N. So therefore, when the switch is at N position, N, the wattmeter reads which value? Means single phase power. Single phase, that's what the first observation. So therefore, let us proceed with the solution. Right, kindly focus. When the switch is at N, what is that? W1 is equal to W2 is equal to W3. They only give each wattmeter reading. That is equal to 577.35 watts. Okay. Sir, under this connection, each and every wattmeter reads which power? Just now I told you. VRN, VYN, VBN. So therefore, each and every wattmeter is reading single phase power. So therefore, I can write V phase, I phase into cos phi. Okay. Sir, if you know the single phase power, can't you get the three phase power? Yes. So therefore, what we can write? Therefore, power 3 phase is equal to, sir, single phase power equal value, W equal, because wattmeter reading they have given equal value. Then what you have to do? Into 3. So therefore, 3 times of 577.35. You will be getting 1732 watt. You will be getting 1732 watt. Now tell me, what is the power 3 phase formula? Already we have taken root 3 VL IL cos phi. So simply I am writing root 3 VL IL into cos phi. So this is the first step. Actually, we have not started the solution, strictly speaking. Given data, slightly modifying. Each wattmeter reading is given, that is reading single phase power, and multiplied by 3 gives 3 phase power. What is the 3 phase power formula? Root 3 VL IL cos phi. Okay, and one more data is given in that. What is that? Apparent power S3 phase is given as how much? 3464 volt ampere is given. So what is the 3 phase apparent power formula? That is root 3 times of VL IL volt ampere. So simply root 3 VL IL. Okay, sir, this is equation 1. This is equation 2, for example. Now tell me, root 3 VL IL cos phi is 1732. Root 3 VL IL is 3464. can we get the cos phi value? Yes. So therefore, what we can write now? From equations 1 and 2, from equations 1 and 2, we are going to get cos phi is equal to 1732 by 3464 watts. 3464. So therefore, you will be getting 1 by 2 means 0.5. Therefore, phi is equal to 60 degrees. In the question, they have given inductive. Therefore, automatically lagging. So therefore, with the given data of what is apparent power, with the given data of individual wattmeter readings, we got the equations from these two. Yes, root 3 VL IL 3464. In the place of this 3464 coming down, that is equal to cos phi. Yes, cos phi 0.5, phi equal to 60 means we have calculator, we are able to calculate what is the value? Power factor angle 60 degrees. Okay, right. Now, what they are asking is very, very important. The next one is when the switch is at Y position, when the switch is at Y position, what is that? When the switch is at Y position, what is the logic? Kindly concentrate. Very, very important observation. Sir, when the switch is at Y, wattmeter 1 R2 Y. So VRY. And current is IR. VRY and IR. So therefore, what is that? W1 VRY IR. After that, anyway, cos of angle between VRY and IR. Very, very simple. Clear? Right. After that, W2. What is W2? VY to Y. VYY itself indicates that VY to Y will be 0. But let us write that VY to Y. Simply, Y you are bringing and Y you are making closed path. So simply, voltage is 0. IY current. So therefore, simply, I am writing the terminology. What is that? W2 equal to VYY IY cos of angle between VYY and IY. So therefore, this will be straight away 0. So straightly, what is that? Straightforward one answer is there. W2 reading is 0. Okay. Now let us talk about W3. W3. What is W3? Kindly focus here. W3. VB to Y. VBY. So therefore, VBY. Anyway, current will be IB. So therefore, VBY IB cos of angle between VBY and IB. Right. Sir, again, after getting the wattmeter equations, we need to draw the phasor diagram. Once we draw the phasor diagram, we can conclude the corresponding point. Okay. In order to draw the phasor diagram, what you require again? VRY means, come on, VRN minus VYN. VRN minus VYN because VRY. And VBY. What is VBY? VBN minus VYN. Right? This is what the point. So what you require? RN minus YN, VBN you require. RY and BY. That's what the point. Now let us draw the phasor diagram here. Sir, this is the phasor diagram I am taking. This is VRN. And this is VYN because RYB sequence generally to be followed. And this is VBN. VRN, VYN and VBN. Okay, right. The question here is, sir, RN is there, right? YN is there, okay, BN is there, but what we require? Minus VYN. So therefore, VYN should be reversed. Okay, before reversing that, what we require here? IR you require, IB you require, IR as well as IB you require. So automatically, what we can say? IR is with respect to lagging. So therefore, here IR, just like the previous model only, but question is different. This is IR. What is angle? this angle is 60. This angle is 60. After that, sir, IB you require, IB. So same logic here. What is this? This is IB. This angle is 60. Just like a previous question. But after the solution, I'll give the small logic, small shortcut, simple point. Without doing this entire thing, you can answer straight away. How? Let us see. What is that? 60, 60 we have taken. Okay. Minus Vyn minus Vn is required. Minus Vn minus Vn is required. So therefore, sir, Vyn is there. Let us reverse it. This is minus Vyn. Okay. Now we need to add the vectors. Vrn minus Vyn. Vrn minus Vyn. Right? If you are adding these two, you will be getting the final vector, that is Vry. Just earlier model only. But different model question, different question. What is this? This is 30. This is 30. If this is 30, what is this angle? This will be 90. Okay, next. Vbn minus Vyn. Vbn minus Vyn. Yes, Vbn minus Vyn. So this is Vby. This is Vby. What angle we require? Vby and IB. So therefore, Vby and IB, this angle we require. Obviously, this is 30. Okay, right. Now, sir, this equation, Vry, IR, cos of this value. So therefore, W1 is equal to Vry, IR, cos of 90. Cos of 90. So therefore, simply 0 watts. Sir, the logic behind this question is, when the switch is moved to Y position, W1 is not taking any load. And W2 already we have taken. That is, which value? 0. It is also not playing the role. So therefore, W2 already 0. Already 0. Now, W3, sir, without doing anything, those who are watching, kindly focus. Without doing anything, W3 straight away we can write or not? Yes, we can write straight away. What is it? 1732 watt. So how can we write? Means, what is the load power in the starting step you have taken? The load power is 1732. What is the total consumed power? In the first case, each wattmeter is equally taking. But in the second case, 2 wattmeter readings are not at all taking. So therefore, total load will be based on the third wattmeter only. But let us proceed. Let us prove that. What is that? Vby. What is Vby? V line. So therefore, Vby. Oh, let us write that. Vby and IB. Vby, IB, cos of angle between Vby and IB. Okay. Now, sir, Vby. What is Vby? Line voltage 400 they have given. But sir, IB, line current or phase current, both same, but nowhere the data is given. So therefore, be clear. Starting step, from this you can get it. From this, IL is equal to line current or phase current, both are same, because neutral wire, star connection only. So therefore, IL is equal to 3464 by root 3 times of VL is 400. If you simplify this, you will be getting the 5 amperes. You will be getting the 5 amperes. So straight away, we can substitute over here 400 into 5. Sir, cos of. What is the angle between Vby and IB? Vby and IB is 30. So therefore, this angle is 30. If you simplify this, 400 into 5, 2000 into 0.866, you will be getting 1732 watts. So therefore, W1 0, W2 0, W3 1732 watts. Okay. Now, let us see the options. What is that? Here, sir, W1 1732, wrong. W1 0, okay, but W2 1732, wrong. W1 some number, wrong. W1, W2 0, W3 1732. So straight away answer will be this. Straight away, answer is this. But, sir, by looking at the thing, you can answer. What is it? Here, sir, first, with this observation, we got W20. So, W20 means, is it acting as a 2 wattmeter method? 3 wattmeters are there, but second wattmeter reading is 0 means it is acting as 2 wattmeter method. Okay, and if the 2 wattmeter method is there, so that what we can say, sir, power factor is 0.5, 2 wattmeter method, power factor is 0.5, one of the 2 wattmeter readings is 0. In that way, straight away, you can answer that, okay, out of 2 wattmeter readings, one will be 0, one will be other value. In that way, logically, you can go ahead. That's what the point. Okay, but unfortunately, in this, here, W30 they have given, W10 they have given. We cannot choose the answer directly, but we can understand that, sir, here 1 wattmeter is 0. I'm coming again. Out of these 3 wattmeters, 1 wattmeter is 0. Happy. Out of 2 wattmeters, what is that? It is called as simply 2 wattmeter method. Under 2 wattmeter, power factor is 0.5 means out of those 2 wattmeters, 1 wattmeter reading will be again 0. So what does it mean? Okay, out of 3, already 1 is 0, and out of these 2, 1 more will be 0. That's what the logic you can. Why I'm giving this shortcut? If you observe this one, if you see the options, luckily, if you have only one option with number, other with 0, you can answer that directly. That is the reason why analysis is very important. If you take any numerical question following the mathematics and leaving, no. After having this entire question like this, you need to analyze this. Okay, this is 0. 2 wattmeters. In the 2 wattmeter method, power factor is 0.5. 1 will be 0. See the options. Suppose luckily, only one option is there with, right? 2 wattmeters, 0 reading, 1 wattmeter, 1 reading, etc. Directly you can take that. That is what the corresponding discussion. Right. Here, in this entire session, it is looking like I solved only 2 questions. But if you understand these 2 questions, procedure and everything, you can solve any question. You can solve any question from the corresponding measurement of power topic. So this is the total discussion I wanted to give you in this session, as this topic is very, very important topic in the measurement point of view. Let us conclude, guys. Kindly prepare well, right? Follow all these things, and based on this, you can solve many number of questions. Undoubtedly, no problem. Okay, guys, thank you.
My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy, and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy, and if you will work hard, you will definitely achieve your goal. Thank you.